awak. Awak yang tu lah. Jangan lupa subscribe channel kita. Tanda sokongan. Terima kasih.
Alright, Assalamualaikum and hi everyone. So welcome back to my channel. So jom kita sambung untuk discuss soalan 21 sehingga 30 untuk set yang keempat. Alright, so jom kita mula. Okay, so question 21. So the length of a pipe, so given that the length of open, this one is open pipe, is 35.5 centimeter. If the speed of sound is given, what is the fundamental frequency of the pipe? Okay, so open pipe, so equation dia apa? So this is very simple. Kita hanya guna equation saja. So equation for Fn is equal to NV over 2L. Equation ini sama dengan string. Open pipe dengan string sama. Closed pipe saja yang NV over 4L. Okay, so V is given here and this is the length. Make sure the length you change to meter, so 0.355 meter. Okay, so we can just really substitute. So we want to find fundamental frequency. Fundamental frequency means that first harmonic. Okay, first harmonic, so N is equal to 1. Okay, so ini kena hafal betul-betul. First harmonic, second harmonic. Kalau soalan sebut the number of harmonics, tak ada masalah. So kita boleh masuk N ini, the number of harmonics. Okay, tapi kalau soalan sebut, contoh dia kata calculate the frequency of the third overtone. Okay, so third overtone berapa? Berapa harmonics? Okay, so kena ingat balik. Okay, fundamental mode bersamaan dengan first harmonic. First overtone bersamaan dengan second harmonic. Second overtone bersamaan dengan third harmonic. Kalau soalan tanya, third overtone dia bersamaan dengan fourth harmonic. Okay, ini untuk open pipe dan juga string sama ini. Okay, tapi untuk closed pipe, you better check dia berbeza. Okay, the number of harmonics hanya melibatkan odd number sahaja. Okay, so now we can substitute F1. Okay, so ini senang sangatlah. Okay, so masukkan saja formula. You boleh dapat jawapan. So the answer is 478.87 Hz. Okay, so the answer is B. Alright, and then question 22. Okay, so question 22. So let's try. So here we have a sound wave emitted from a point source uniformly travel in all directions at the rate of 1200 watt. Okay, so tengok pada unit, so kita tahu ini adalah power. Okay, 1200 watt. Okay, so if no energy is lost as the sound travels outwards, calculate the intensity of the sound wave at a point of 60 meter from the source. So R is equal to 60 meter. So we want to calculate the intensity. So we just use equation of intensity is equal to power over area. Okay, so this is the area of the sphere. So equation area ni jangan salah. So dia adalah 4 pi r squared. Okay, so 4 pi r squared. So you masukkan nilai dia. So you akan dapat I is equal to, okay, you just substitute 4 pi. R is 60 squared and the answer is 2.65. Alright, 2.65 times 10 power of negative 2 watt per meter squared. Okay, so the answer is C. Okay, good. Alright, next question number 23. So this is about, this one is Doppler effects. Okay, so look at here. Okay, a train's whistle is emitting sound of frequency 500 Hz as the train move. Kita ada train, dia ada whistle. Okay, and the train is moving with a speed of 20 meter per second. So let's say this is the train. Okay, and the frequency of the sound ataupun frequency of the source produced by the train whistle is 500 Hz. And it is moving in this direction, V of the source. Okay, source tu dia lah mengeluarkan train tadi yang mengeluarkan bunyi. So 20 meter per second. Boleh And the train is moving directly towards a stationary observer. Siapa yang tak bergerak? Observer ini yang tidak bergerak. So, V of the observer is equal to 0 meter per second. Okay? Dan train tadi mengeluarkan bunyi, betul? Dan siapa yang nak dengar? Observer yang nak dengar. So, bunyi yang dikeluarkan akan travel towards the observer in this direction. So, saya akan lukis macam ini V saya. Which is V of the sound in air is given 330 meter per second. Okay? So now, okay, kita nak kira apa? What is the difference between the frequencies of the sound heard by the observer before and after the train has passed the observer? So this one before. Dia menghampiri observer. Kat sini after. Okay, so bila after means that the train is moving away from the observer. Dia bergerak ke sini. Vs dia adalah 20 meter per second. Okay, they still emit sound 500 Hz. Okay, but at this point, okay, pada keadaan ini, okay, pada situasi ini, keadaan ini, okay, the sound wave is travelling towards the observer. Direction dia ke mana? Direction dia ke sini. Macam ni. Okay, so V dia ke sini. So the speed of sound in air is equal to 330 meter per second. Okay, penting kenapa saya lukis? Sebab supaya awak tak silap positif and negatif. Kalau you hafal okay, tapi kalau you tersilap, you kena lukis lah. Okay, so bagi saya ajar student, okay, awak selalu ingatkan. Okay, general equation untuk Doppler effect apa dia? FA is equal to V plus minus V observer over V plus minus V source darab dengan frekuensi dia kan. So ni general equation. So positif negatif you jangan salah. Okay, sekarang kita buat dulu. Kita kira dulu sebab kita nak kira perbezaan difference between frekuensi yang didengar oleh observer before and after. Okay, so kita akan buat dua-dua lah. So kita akan start dengan before dulu. Before saya gunakan hijau. Okay, so before. Okay, so ini before. Sekejap. Okay, sekejap ya. So before. Okay, so siapa yang stationary? Observer lah. So dia akan jadi VO kosong. So yang ke atas akan jadi V sahaja. Over V of the source. Okay, ini trik dia lah. Okay, saya selalu ingatkan tengok direction antara V dengan Vs. Okay, you tengok dekat sini, direction of V is to the right and the direction of Vs, the speed of the source. Okay, ataupun the speed of the train tadi is 20. Dia bergerak 20 meter per second and the direction is also to the left. To the right. Okay, so kalau you tengok dekat sini, direction mereka sama. So bila same direction, okay, bila same direction dia adalah negatif, bila opposite direction dia adalah positif. Ingat So sekarang the same direction, right? So V minus Vs. So ini untuk memudahkan awak ingat, times dengan Fs. Okay, so kita boleh masukkan nilai dia lah. Berapa nilai dia? Okay, saya akan kira kat sini. Ini before. So, V dia adalah 330 over 330 minus 20 times 500 Hz. So, the apparent frequency ataupun frekuensi heard by the observer, okay, is equal to 532.258 Hz. Okay, kita belum lagi menjawab soalan. Okay, kita perlu kira pula. What is the frequency when the train is moving away? So, ini after. Okay. After. So, dia akan jadi apa? FA. Okay, sekarang tengok pula direction. Sama je macam tadi. Konsep dia. Okay, V plus minus V observer 0. Tak payah tulis lah. Okay, so V plus minus, plus or minus. So look at the direction. Okay, direction siapa? Direction V ini to the left. Tetapi direction VS is to the right. They are opposite direction. So ini saya akan letak. Kalau tadi kita adalah negatif. So this time is positive VS. Okay. So cara you tulis equation kena betul lah. Kalau tak, you akan salah kira. Okay. So you akan dapat nilai dia 471.429. Kalau you nak tengok betul ke tak yang you kira tu logik ke tidak. Okay, secara logiknya kalau train mendekati awak, kita akan dengar lebih kuat. So the value of apparent frequency heard by the observer should be bigger than 500 Hz. So betul kita kira. But when the train is moving away from the observer, the value of the frequency that heard by the observer is less than 500 Hz. So betul lah. Okay. Tapi soalan minta kita kira apa? Soalan minta kita kira the difference between frequencies of the sound heard by the observer before and after. So saya akan kira delta F is equal to F before minus F after. Okay. So masukkanlah nilai yang you dah kira tadi. Okay. Which is 532.258 minus 471.429. Okay. And the answer is 60.8 Hz. Okay. So jawapannya adalah D. Okay. Tengok balik soalan tadi. So the answer is D. Okay. Alright. Next, question 24. So this is from chapter 11. Okay. So a metal bar that has cross-sectional area of 4 cm squared. So A, check. Dia bagi dalam 4 cm squared. Tolong tukar kepada meter squared. Kalau tak tahu tukar, tak boleh lagi you nak pergi ambil exam. Nanti salah. Okay. And the length of the metal bar is given. Okay. So, okay, L 50 cm. Okay. And the metal bar is stretched by a force F. This one is 10.0 exponent 4 Newton. And find the stress. Okay, so we want to calculate what is the stress of the wire. So, senang sangat kan? So, formula stress is equal to F over A. So, you masukkanlah. Cuma jangan silap dekat sini saja. Area tu mesti tukar kepada meter. Okay, you substitute all the values, you akan dapat 3.5 exponent 7. Sorry, 2.5. Okay, tekan calculator check Newton per meter squared. So the answer is C. Okay, so next one, question 25 from chapter 12. Okay, so kita cuba. The rate of heat conduction. Okay, the rate of heat conduction is 80 kilojoule per hour. Okay, perkataan the rate of heat. So this one is dq over dt. So dq over dt dia bagi dalam 80 kilo power of 3 per hour. Okay, kalau per hour tu dia adalah 3600 second. Okay, so the answer is 22.22 joule per second. Okay, so dq over dt. And then it's given that the area, so make sure you check the area because the area is in centimeter squared. So you need to change to meter squared first. Okay, so 14 centimeter squared is equal to 14 times 10 power of negative 4 meter squared. Tukar ni jangan salah yang ni. Okay. Alright, so given that the temperature gradient dt over dx is equal to berapa tu? 15 15 degrees Celsius per meter. Jadi untuk temperature gradient ni saya akan letak negatif. Kenapa saya letak negatif? Okay, cuba awak ingat semula. dt ini adalah T final minus T initial. Okay, and heat transfer from higher temperature to lower temperature. So means that T initial ini temperaturenya lebih besar daripada T final. Kan? Okay. So maknanya kalau T final nombor lebih kecil tolak nombor lebih besar, so you akan dapat negatif. Okay. So sebab itu sini kita negatif sebab ini. Okay. Sebab ini tadi. Okay. So sekarang kita nak kira apa? Soalan minta kita calculate the thermal conductivity, which is K. Alright. So general equation dQ over dt is equal to negative Ka dt over dx. Okay. So daripada sini kita boleh kira K lah. 22.22 negative K. So A is 14 times 10 power of negative 4. Lagi. Dt dx is negative 15. Therefore, K you akan dapat 1058.09 watt per meter per Kelvin. Okay, so the answer is C. Alright, so next, question 26. Alright, so what is the change in area? Okay, so in centimeter. Okay, so this is in centimeter squared of a 60 centimeter by 150 centimeter car windshield. Okay, so this one let's say, contohlah macam ni kan. So this is 50 centimeter, sorry 60. So 60 times 150 centimeter. Okay. When the temperature T final, T initial dia kosong, T final 36 degree, T initial dia adalah 0. So given that the coefficient of linear expansion. Okay. So ini adalah perangkap awak lah. Cerita pasal area. Tapi bagi linear expansion. So maksud dia apa? Dia bagi alpha. Okay. The value of alpha is equal to 9 exponent 6 degree Celsius negative 1. Tetapi bila kita nak kira the change in area which is delta A, kita cerita pasal area dan kita perlukan apa dia? Area, coefficient of area which is beta. Di mana nilai beta adalah 2 kali alpha. Ini yang you tak boleh lupakan. Okay. So sekarang you nak kira delta A. The change of area formula dia apa? Beta times A0 initial area times the change of temperature. Okay, so this is the equation that we want to use. And then let's substitute beta, So beta is equal to 2 kali alpha. Kan? So kita boleh masukkan semua nilai. Okay, we just substitute. A0 kena kira lah. A tadi kita tak kira lagi. Di mana A0 kita adalah 60 cm times 150 cm. Okay. So kalau kita kira, saya akan dapat berapa tu? 60 times 150. So is it 9,000? Awak cuba kira. Okay. 60 times 150. Okay, so betul lah 9,000. Sorry, 9,000. So 9,000 and 36 minus 0. So delta A is equal to 5.83 centimeter squared. Okay, so the answer is D. Senang je kan? Okay, question 27. Tengok saya buat memang nampak senang. Cuba buat. You tutup. You dah belajar, you tutup. You cuba buat semula. Buat beberapa kali. Boleh buat tak? Okay. So 27 from chapter 13. So we have a gas of mass 0.3 kg. So saya akan keluarkan semua maklumat. And then given that the volume is 0.5 meter cube. And then pressure is equal to 1.4 exponent 5 Pascal. Okay. Alright. Determine the RMS speed of the gas molecules. So we want to calculate VRMS. Okay, we just use the equation. Square root. Kita dah ada pressure kan. Okay, bila soalan bagi M dengan V ni, automatically saya tahu, oh ni mesti nak boleh cari density. Which is M over V. Okay, so kita bolehlah guna formula ini. 3P over density. Okay, where this one is M over V. Okay, so just substitute all the values given. Okay. And M over V. M is, check betul-betul M mesti dalam kg. Volume mesti dalam meter cube. Kalau dalam centimeter cube, you tukar dulu. Alright, jangan careless. So the answer is 836 yang saya dapat So the answer is B. Okay. Finish. And then 28. Okay. So here we have a tank. Has a volume of 0.7 meter cube and contains 2.5 mole of helium gas at 10 degrees Celsius. If helium behave like ideal gas, calculate the total translational kinetic energy of the molecule of the gas. So we want to calculate the total translational kinetic energy. So K translational, okay, this one's for total. Okay. Is equal to 3/2 nRT. Ini guna satu equation je, you dah dapat jawab. So 3/2, the number of moles is 2.5, R is 8.31. The temperature, make sure you change to Kelvin. So 10 plus 273.15, 283.15. Okay, therefore the answer is 8.82 exponent 3 joule. Okay, so the answer is A. Next, question 29. Sikit lagi nak habis. Okay. So for question 29, referring to the PV graph, okay, an amount of 160 joule of heat is added to the system in process A to B. Okay, sekarang saya akan highlight sikit. This is AB. Okay. And then, while in the process of BD, 600 joule of heat is added. So B to D. Okay, so A to B constant volume, kan? A to B adalah constant volume, so isochoric. Okay, so kita akan buat dulu A to B. Okay, saya akan highlight ni warna kuning, warna biru. Okay, so this one is isochoric. Always remember, constant volume, W is equal to 0. Saya hanya tulis saja dulu. Okay, saya belum baca soalan. Okay, and given that 160 joule heat is added. So positive 160 joule. And then for BD, untuk proses B to D, that one is isobaric because constant Awak tengok dekat sini. Okay, proses dia B to D, constant pressure, so isobaric. A to B is isochoric, constant volume. Okay, so B to D, and it is equal to, sekejap, saya tulis dulu, isobaric. Okay, so for isobaric, kita kena kira dulu. Okay, QBD dia bagi tadi, 600 joule. Okay, isobaric, W tak kosong W kita boleh kira. Where WBD is equal to P delta V. Okay, you need to use this equation. Okay, so you can find P, but dah bagi 10 power of 5. Exponent ni jangan tertinggal dalam equation, dalam calculation. Okay, and delta V dia adalah 0.6 tolak 0.2, saya terus tulislah 0.4. Okay, times 10 power of negative 3. So W ini awak kira, WBD ni saya dapat 400. Is it 400 joule? Okay. So we want to determine the change in internal energy in the process ABD. So for the whole process, we want to calculate the change in internal energy ABD. So kalau saya nak kira, okay, U, delta U, ABD. So it is equal to delta U AB plus delta U BD. So sebab tu kita buat satu-satu. Kita buat AB dulu. Kita cari dulu delta U AB. Okay. So delta U AB, kalau W equal to 0. So based on first law of thermodynamics equation. So Q is equal to delta U plus W. Kan? Ingat tak formula ni? Okay. So, kalau W kosong, automatically delta U AB is equal to Q, iaitu 160 joule. Okay. And then for BD, kita pun sama juga. Q is equal to delta U plus W. Okay, saya highlightkan sikit. Sekejap. Saya highlightkan sikit. Therefore, delta U untuk BD is equal to Q minus W. Q dia tadi berapa? 600 minus 400. It is equal to 200 joule. Okay. Therefore, okay, the change in internal energy for the whole process ABD is equal to 160 plus 200. And it is equal to 360 joule. Okay, so the answer is C. Okay, and the last question for set 4. Yay, dah nak habis dah. Okay, so we have an ideal gas at a pressure of 1 exponent 5 Pascal. So P, okay, this is given P and the volume is given. Is heated at constant pressure until its volume achieve 1 meter cube. So the first process is constant pressure. Okay, so constant pressure. So this one is isobaric. So kita nak kira apa? The total work done. So bila total work done, okay, kita mesti nak kira nantilah W masih dekat sini. Okay. And for the second part, the gas then heated. Second process, the gas then heated at constant volume. So this one is constant volume. So this one is isochoric. Okay, always remember, okay, bila constant volume, W work dia adalah kosong. Okay, so kita kena kira kat sini sajalah kan. W is equal to P delta V. So P dia dah bagi 1 exponent 5. V dia tadi 1.0 minus 0.4. So W yang pertama, ini W yang kedua. So this one is 60,000 joule. Okay. And therefore, the total work done is equal to W1 plus W2. So W1 is 60,000 tambah kosong. Dapatlah 60 kilojoule. Okay. So jawapan dia adalah C. Alright, so finish all questions for set 4. So see you in the next video kalau ada lagi. So saya rasa set yang terakhir adalah set 5. Okay, so itu adalah terakhir dan saya ucapkan semoga awak maju jaya dan rajin dan teruskan usaha. Assalamualaikum dan selamat sejahtera. Jumpa lagi. Bye-bye.